Hi, in this video I'm going to show you how to calculate question 2 in the assignment. This question asks about the confidence interval and the prediction interval from a specific prediction. So here in this case we have a data set that shows several values of x1 and x2, and these are the independent variables, while the dependent variable is y. So we're going to run a regression analysis, and from there we are going to find if for this specific prediction the confidence interval around that and the prediction interval. All right, so the steps for this kind of calculation is a little bit not that straightforward, as I told you earlier. We're going to start with copying and pasting the values. Take that to our Excel. That's the first step. So I prepared these inputs. So that's alpha. K is the number of independent variables that we have. P is that number plus 1. So there is an embedded function. N is the total number of observations, which is basically all the data sets and all the data points, I'm sorry. And then we have T critical. All right. So when I copy that, I have to make sure that I don't copy everything because I don't want this to be pasted over. So I'm going to copy just the values and then paste that right here. So I'm going to need what we call x0. So x1 is associated with the first slope, b1. x2 is the variable that is associated with b2, the second slope. But if we want to consider the intercept, it's going to be a fixed number, like 1 times the intercept. So we're going to add that. We're going to need to add that for this specific calculation. So we're adding x0 in this case. Okay? And that's going to be 1, 1, 1 for all the observations, and that's because there is no variable. It's just like 1 times the intercept that we get from the regression analysis. Now we need to run the regression analysis. So we go to data, data analysis, regression. And then we're going to try to highlight y, and then x is going to be x1 and x2. We have 2 variables in this case. Then we're going to make sure that we check the label, and we can paste the results whatever. So let's choose F here so that we see that, and we click OK. So now we have all the coefficients, and we can construct a function for that prediction. So we have our inputs are, we have x1 equals 9, x1 equals 9, x2 equals 14, and x0 is always 1 because that's the coefficient here. So y hat in this case is going to be, so these are the coefficients, and the reason I arranged that this way is that I wanted to use the sum product function. Sum product function, all you need to do is to highlight or select this range for the first array and then this range for this array, and then we click OK. So this gives us the prediction. So around this prediction there is a confidence interval and there is a prediction interval, and that's what we're trying to calculate. The first part of this question asks about the confidence interval, and that range uses a function or a formula that looks like this. I'm not going to go into the details of that, but I have it plugged in already, and it will capture references like cells from the different references here. So all you need to do is just to understand what I did here, and then going forward you basically need to change the inputs in line with the question inputs. All right, so in this question alpha is not specified, or it is here, so we have 95%. So alpha is 5% in this case. So this is going to be 0.05. K is, we have 2 independent variables. So that's going to be 2. So P is captured automatically. N is going to be the number of values here. So we know that we have 8 values. If we select that, we can see here, you can see that these are 8 values. So we can type 8, and then we're getting from there, because I have that already as T critical. We have that here already. So we have T critical here calculated, and this is calculated because it's required for this big formula, as you can see here. Okay, so it's required, it's referenced. You don't need to do anything. All you need to do is to calculate or plug in the numbers, and once it's captured, once you calculate T critical, it's going to be part of that. The one thing that you have to capture here is the standard error. So you can see here, H7 was supposed to be standard error, but then I'm going to place it correctly here. I'm going to do that for all of them. Place it to the standard error. Standard error of the prediction and confidence interval captures, it's like the standard deviation for any other estimate, but since the regression has its own thing, we have to use the standard error. All right? Now, the last thing that we would do is the long process. The reason that why we have x0 here with all these ones. So we're going to use sum product. So basically, the product, the summation of this column times this column, and then we're going to create a matrix of these operations. So for this one, it's going to be this column times itself. When we move to the next one, it's going to be this column times this one. And then for this one, it's going to be this column times the third one. And then when we go down, we're taking this as the second row. So it's going to be this column times the first one, and then this column times itself, and then so on. So I hope that you capture the logic here. The logic is basically we're taking turns in what is going to be sum product. So sum product, this column times itself, because that's the first part of the corner. Not sure if you understand what I'm trying to say, but I hope that with taking some time to understand what's happening here, you can get the logic here. Sum product. So because this position is the second one, and then it's the first row, so it's going to be this one as the first row. This represents the first row, but then the second position, which is represented by the column of x1. So that's why it's going to be sum product of these two. And then as for the third one, it's going to be sum product of first row times third. Okay, so these represent these three positions. When we go to the second row, then it's as if we are looking at this, but it's transposed. Okay, so now the base is the second column here, as representing the second row here. It's going to be sum product of this, but since this is the first cell in that row, it's going to be this one, 0. As we move to the next one, this is going to be the second sum product itself. Oh, I forgot sum product of this range times itself, and then the second again, sum product. So that's a little bit a long process. That's why you should do it once, and then if you know how to do it, try to sort of have it plugged in. You can capture it just by plugging in inputs. All right, so that was the second one times the third column. So now we're moving to the third row, and the base this time is going to be the third column. So we're starting always here, while the second range is going to be the one that is corresponding to the cell. Sum product again. The base for that is the third row times second one, while the third is sum product of the third times itself. Okay. With that, we have, this is step one. We have this range. It's all sum products according to the logic I explained. Now we're moving to what we call M inverse. That's step two. I'm gonna clean that out so that you see what happens here. Here I'm going to use M inverse. M inverse, it's a function that returns the inverse matrix. The whole matrix is going to be inversed. Okay, so all I need to do after that is to actually highlight or select the range in this case, and it's going to return that. So this whole thing now is inversed. With these inputs, this is going to be captured here, and I can show you where that is captured. You see M multi, I mean, for you, this is, and you have transpose too. So you have several functions that you're probably not familiar with. All you need to do is that you're capturing the M inverse of this range, okay? And I have all the functions plugged in here. All you need to do here is to basically copy and paste. This is the lower confidence limit, and this is going to be the approximate to, we have to round it to 2 decimals, so it's going to be 12.57, and the upper limit is going to be 21.48. Check the answer, and that's correct. So what did we do here? we plugged in values to predict the y, or basically the dependent variable value. When we try x1 and x2, so when x1 equals 9 and x2 equals 14, that's 17. That gives us 7. It returns 17. But then around this specific estimate returned by the regression equation, there is a confidence interval. And the way you actually generate that is using this long procedure. And then if the question goes on and asks for prediction interval, you pick it up from here, right? This was it for this video, and let me know if you have questions about this.